Students, so I will talk about fuel cells in this lecture. Fuel cells are those cells which generate electricity from an electrochemical reaction in which oxygen from air and hydrogen, they combine to form water. So this is actually the fuel part, and this is supposed to be an electrochemical reaction. Now, the electricity produced from fuel cells are used in many areas. They have got many applications. They are used in power cars, or automobiles, and they are also used to charge laptops, mobile phones, and other electronic gadgets. And the structure of a fuel cell is pretty simple. It consists of two electrodes, anode and cathode, and positive and negative. And there is an electrolyte, a typical electrochemical cell, and a catalyst, which in most cases is platinum. And the electricity is generated when the oxygen and hydrogen combine to form water. Now there are different kinds of fuel cells. We will first talk about a fuel cell called the proton exchange membrane fuel cell. It's called PEMFC. Now, as you can see from the name, there is a membrane which actually is used in transfer of hydrogen ions. Now, by protons, we basically mean H plus ions, and these ions, they actually move in the electrolyte inside the cell, whereas due to its movement from the external circuit, electrons flows. So that is how the current is generated. Now, coming to its electrochemical part, so now as we know, there are two electrodes. One is your anode and another one is your cathode. At the cathode, which is where the oxygen enters, the oxygen is reduced. It means oxygen having -2 charge, it gets reduced with the help of protons and it forms water. However, at the anode part, hydrogen gets oxidized and it turns into H plus ions. Now, as we have said that there is a membrane, so there is a proton exchange membrane separating these two. So this is how the electron is flowing outside the circuit, and this is where the proton movement is taking place. So considering the overall reaction, we can write it is like this: 2H2 gas plus oxygen gas. These are the inputs. This one goes at cathode, this one as anode. So let's put it here. E and C, they will combine to form H2. That's it. And the energy, electrochemical potential, is 1.23 volts. Now, the importance of the proton exchange membrane is the electrolyte. So, let's talk about this PM. Now, the electrolyte must allow only the appropriate ions to pass through. Okay, and it should block other ions. So that is the role that plays played by the proton exchange membrane. So it screens the ions passing in the electrolyte. This is the proton exchange. Now, what is the advantage of using a fuel cell? Why should we use fuel cell? So, why fuel cell? First reason is that the society is mainly dependent upon three main fossil fuels: coal, oil, and gas, and they are getting depleted. And also the byproducts like carbon dioxide are causing are hampering the atmosphere. So to reduce uh, fossil fuel consumption, we need to switch to alternative sources of energy, and one of them is your fuel cell. Now, what are the limitations that we face while creating or applying a fuel cell for practical use? First limitation is of storage. How do we store it? Or in fact, how do we store the hydrogen, which is the fuel in a fuel cell? That storage, that part is important. And then, of course, related to this is the transportation. We need to transport the hydrogen to the appropriate place where it will be used ultimately in the fuel cell. That transportation is important. So, and also lastly, there are some toxic chemicals which may get produced in the cell which needs to be sorted out. Otherwise, it may cause some environmental problems. Okay. So these are the limitations. Now, there is another type of fuel cell called, this is in fact the most used fuel cell, that is called SOFC, or a solid oxide fuel cell. It stands for solid oxide fuel cell. So from the name itself, you can understand, so instead of using a liquid electrolyte, it uses a solid ceramic electrolyte, and electrolyte is basically zirconia or yttrium oxide, or 2 or 3. These are the two materials which are widely used in the solid oxide fuel cell. Advantage of an SOFC is it can work at high temperature. So SOFC it can work at high temperature. Secondly, it can reach an efficiency around 60%, which is quite high. And these are the two main advantages. And for an SAFC, another type of fuel cell are called metal air fuel cell. Or MAFC. And it is actually not a conventional fuel cell, but it is mainly used in to work like batteries and generate electricity. The advantage of this is rechargeable. Now coming to its efficiency of a fuel cell. It is actually defined as a percentage of useful electrical energy produced, percentage of useful electrical energy produced relative to heat that would have been obtained by combustion of the fuel. Combustion of the fuel would have produced some amount of heat. So the percentage of electrical energy produced relative to that is called the efficiency, or it is also known as the enthalpy of formation. Enthalpy of formation. So mathematically you can express the efficiency as delta G by delta H. Delta G is the change in Gibbs free energy, and for an hydrogen oxygen fuel cell, the maximum achievement fuel cell is 83%. So we can write is equal to 0.83 V cell by V ideal. That is in an ideal case. Then the 83% is the amount of energy that is the amount of efficiency that one might achieve. So this is the maximum efficiency a fuel cell can have. Okay. Now coming to the losses, usually why it is not 100%? What are the possible losses in a fuel cell? So there are mainly three types of losses. First one is called the activation polarization. The second one is ohmic polarization. And the third one is concentration polarization. So you can see that in all the cases there is this term polarization. Polarization means how you are separating and the positive and the negative charges, because the more you separate the positive and the negative charges, the recombination probability reduces and hence the efficiency reduces. So therefore it is considered as a loss. So we will take up one by one. First of all, we start with activation polarization, or active polarization for that matter. It is caused by limited reaction rates. At the surface of the electrodes, at the electrode surface, and it is mainly dominant at low current density and increases marginally with increasing current density. It is dominant at low G by G, we mean current density, and increases marginally as J increases. Ohmic polarization is again, so the second one is your ohmic polarization. It is caused by that. From the name you can understand it is based upon this Ohm's law, and it is caused by the resistance to the flow of ions in the electrolyte. Resistance to flow of ions in the electrolyte. And also to the flow of resistance to the flow of electrons in the electrodes. And this resistance is directly proportional to the current density as in the Ohm's law. And lastly, we have concentration polarization. Concentration polarization is nothing but due to a difference in concentration of the electrolyte. We actually get such type of polarizations. So, as the reactant is consumed at the electrode, so we have a reactant, so like oxygen and hydrogen. So when the reactant is consumed at the electrode, due to instability of the surrounding material to maintain the initial concentration of the fuel. So instability in the surrounding concentration causes a polarization, and basically there is a concentration gradient formed in the electrolyte, so that gradient is responsible for the loss. Now we have mathematical expressions for the three different types of concentration that we have talked about. For example, the activation polarization, that is given as L activation, the loss due to activation polarization is equal to RT divided by alpha F into ln I by I0. I0 is the exchange current density, so this is the exchange current density, whereas alpha is the electron transfer coefficient. Ohmic polarization, on the other hand, is just the Ohm's law. Is simply equal to I into R. Whereas the concentration polarization, L concentration, is equal to one minus I by IL. Well, IL is called the limiting current. That is, the had it been no concentration polarization, what would have been the current? That is called the limiting current. So any current apart from that will take a ratio, and you put it in this equation, you get the two different types of polarization. Now we draw a chart seeing the effect of these three polarization. So we draw a chart like this. We plot the current density I or J, or you can put it as I because this is used here I. So we put I, which is milliampere per centimeter square, and if we put cell voltage V here, and if we consider this as the ideal voltage, so due to loss the shape is like this. Use a different color. Due to the loss the shape is like this. So this is initially there will be an active polarization. So this is the case of L active, a loss due to active polarization. In between, when the current actually starts to flow, it will be ohmic polarization. And at the electrodes, when there is a concentration gradient after some amount of current has passed, and then lastly we have a concentration polarization. So these three polarization actually are the losses at the fuel cell phase.